If a human spends 365 days on Mars, the human body could face damage from 5 different deadly threats: radiation, low gravity, extreme cold, toxic dust, and isolation. Mars might look like humanity's future home, but scientifically, it's one of the most hostile environments in the solar system. The atmosphere on Mars is about 100 times thinner than Earth's. That means the planet offers almost no protection from space radiation. On Earth, our magnetic field and thick atmosphere block most dangerous cosmic rays, but on Mars, that natural shield is almost completely missing. Scientists studying Martian conditions estimate that astronauts living there could receive up to 700 millisieverts of radiation in a single year. For comparison, the average person on Earth receives about 2 to 3 millisieverts per year. That means 1 year on Mars could expose a human to over 200 times more radiation than normal life on Earth. This level of radiation significantly increases the risk of cancer, brain damage, and organ failure. And radiation is only the first problem humans would face on the red planet. Because once humans actually start living on Mars, another serious problem begins to affect the body almost immediately. And it starts with something we rarely think about on Earth: gravity. The 38% gravity problem. Mars has only 38% of Earth's gravity. At first, this might sound like a benefit. Imagine jumping 3 times higher than you can on Earth, or carrying heavy equipment that suddenly feels much lighter. But human biology evolved under one constant force: Earth's gravity. When gravity drops below normal levels, the human body begins to change in unexpected ways. Data from long-duration missions aboard the International Space Station shows that astronauts can lose up to 20% of muscle mass in less than 2 weeks without constant exercise. Even with strict exercise routines of 2 hours per day, muscle strength still declines during long missions. Bone loss is another major concern. Researchers studying astronauts in orbit have measured bone density loss of about 1% every month. That means after 12 months, an astronaut could lose around 12% of their bone density. For comparison, people on Earth lose only 1% of bone density per year after age 50. But Mars gravity is not zero like space, so scientists still have one big unanswered question: is 38% gravity enough for the human body to stay healthy? Right now, the honest answer is no one knows for sure. And that uncertainty alone makes long-term survival on Mars a huge experiment. But gravity is still not the most extreme challenge humans would face there, because the environment of Mars itself is brutally cold. Temperatures that can freeze a human in minutes. The average surface temperature on Mars is about -60 degrees.
That's colder than the coldest winters in most places on Earth. But the average temperature doesn't tell the full story. During nighttime, temperatures on Mars can drop to -80 degrees Celsius, or even -100 degrees Celsius. And near the polar regions, winter temperatures can fall below -125 degrees Celsius. At these temperatures, exposed human skin could freeze in less than 1 minute. Even advanced spacesuits must constantly generate heat to protect astronauts. But the real challenge is not just the cold, it's maintaining stable temperatures inside a habitat for 365 days straight. Heating systems must run continuously. If a power failure occurs during a Martian night, temperatures inside a habitat could begin dropping within minutes. Which raises another critical question scientists are still trying to solve. How do you build a base that can survive Mars for years without failure? Because Mars has another environmental threat that makes engineering extremely difficult, and that threat comes from something that looks harmless at first: dust. The dust that can shut down an entire planet. Mars is covered with extremely fine dust particles. These particles are much smaller than typical dust found on Earth. Many researchers describe Martian dust as being almost like microscopic powder. Because Mars has weaker gravity, this dust can stay suspended in the air for long periods. And sometimes something incredible happens. Local dust storms begin growing larger and larger until they transform into planet-wide storms. Observations from orbiting spacecraft have shown that some Martian storms grow so massive they can cover the entire planet. These global storms can last several weeks or even months. During one such storm, sunlight across Mars dropped dramatically. Solar-powered equipment suddenly lost energy. This is exactly what happened to the Opportunity rover, which stopped operating after a massive dust storm blocked sunlight from reaching its solar panels. But dust storms cause more than just power problems. Martian dust also contains toxic chemicals called perchlorates. These chemicals can interfere with human thyroid function and other biological systems. If dust enters a habitat or airlock, astronauts could be exposed to these compounds over time, which means dust on Mars isn't just a nuisance. It could become a long-term health hazard. And yet, even dust storms are not the biggest psychological challenge astronauts would face, because Mars is not just hostile, it is also incredibly lonely. The loneliest place humans have ever lived. Mars is separated from Earth by distances ranging from 55 million kilometers to more than 400 million kilometers. Because of this distance, communication signals take time to travel. Even at the speed of light, messages between Earth and Mars take between 5 and 20 minutes one way. That means a simple conversation could take up to 40 minutes. Astronauts cannot have real-time discussions with mission control. Every decision must be made largely on their own. And then there is the psychological environment. For 365 days, astronauts would live in a world with no oceans, no forests, no wildlife, no natural sounds, just endless red landscapes stretching across the horizon. Researchers studying isolation during simulated Mars missions have found that long-term confinement can cause sleep disruption, stress, emotional fatigue, and interpersonal conflict. Even highly trained crews begin to feel the psychological pressure after months in isolation, which raises one final and important question. Even if humans can physically survive Mars, can they mentally handle living there for an entire year? The real challenge of living on Mars. When all these dangers combine, the challenge becomes clear. Radiation levels 200 times higher than Earth. Gravity only 38% as strong as Earth. Temperatures falling below -100 degrees Celsius. Planet-wide dust storms lasting months, communication delays of up to 40 minutes, and complete isolation from the rest of humanity. Surviving on Mars for 365 days would require some of the most advanced life support systems ever built. Without them, the red planet could quickly become one of the most dangerous environments humans have ever tried to live in. Mars may be humanity's next destination, but spending one full year there would test the limits of human biology, technology, and psychology. And scientists are still trying to answer the biggest question of all. Can humans truly live on Mars, or will the planet slowly destroy the human body?